You know, guys, I always say in all my lectures, courses, and tweets and YouTube videos that the most important thing for a backend engineer to understand is networking. Truly, truly, because that's the frontier, if you will, that bridges you between the front end and the back end, that networking. And I think it's also fundamentally true for front end engineers to understand how networkings work and truly just invest the time to understand these basic, networking fundamentals, which is I talk about in my network course and extensively in my backend course. But this is the Node.js course, and of course we're going to talk about networking here. But I'm going to link it specifically to Node, and so you can feel it. Although it's not fundamentally any different, it's just the abstraction that Node has is almost one-to-one to what we have in the Linux kernel and in the networking stack, essentially. However, there are some slight differences that you need to understand, and thus this lecture. How about we jump into it and discuss? I see networking to be summarized into these 4 bullet points. I don't think there are the other options there. You see, the way I look at networking and Node can act either as a client or can act as a server. Right? You can have it as a client or you can have it as a server, a front end or a back end. And the same Node backend can also turn around and act also as a client to another server. That is definitely possible. And by understanding this fundamental concept, you're ready to get started. See? That all of this is because I have this client or server. If I am at the client side, I can choose to connect to an existing listening server. And that creates connection on the client side. So I am at the client side and I want to connect to a server. So there is a connection at the client side, an object, a socket at the client side. And using Linux speak, because that's what we mainly run on, this is a file descriptor that is uniquely identified for a given process. And that's the Node.js process. So that's one way to do it. You create a connection at the client side. And the other side of it is you have a server-side listening socket. You have an existing listening socket. Let's say this is a listening socket, and I used green here. And then you can accept connections on that listening socket. That act of accepting connections from existing or suppose new clients, right? That in itself creates a new socket that represents the connection at the server side. So you have a front end that has a connection object, a socket, because it connected to a server. Then you have the server that have an existing listening socket that you created and you listen on port 8080. But then every connection that is accepted, which is very critical to understand the word accepted here, creates a new socket. And that socket also gets its own unique file descriptor, new object. And that is one-to-one to that. That's a bridge between the client and the server. Capish? So that's the major thing here. And you can have multiple connections connected to another server, another connection to another server, to the same server, another connection from different clients even. Let's say this is another laptop. So this is a connection. So you have, in this case, I have 4 connections and 1 listening socket and 4 connection socket, right? Whatever the naming convention might be. So then we have the connection at the client side and we have a connection at the server side. You can choose to read data from a connection, reading data from connection, reading data from connection, reading data from a connection, writing data from the connection. You cannot write or read anything from the listening server socket. It doesn't make sense. You read and write to a connection. And naturally, if you have a server and you write to a connection, that is an indication that you're responding to the client, right? That's how HTTP works, right? But HTTP is a request response system or protocol, to be particular about it. And that is just how HTTP did it. TCP doesn't have this directionality at all. You can, the server can just talk to the client at any time. But HTTP created this protocol that says, hey, a client must make a request and a server responds to a request, right? Which we're going to talk about in the HTTP section, but that's just there. And you can, reading data from a connection is applicable for both client and server, yes, but only on connections, all right? Writing data to a connection is also applicable to client and server. If I write something in the connection side, and the client side, that data is being sent from my process, that is node. I wish I had a better pen. This trackpad sucks. This is my process, and then that looks like something else. Now go to my kernel, which is also living in my same machine, kernel, and then that goes to the TCP/IP protocol, and that goes to the network as bits, whether it's fiber light on fiber, radio waves on Wi-Fi, or electrical pulses on Ethernet. It doesn't matter. It's a medium. So yeah, I love this feature to draw on slides. I just discovered it the other day. Some of you guys is like, what age are you living in? You just discovered how to draw. Okay. You know, there is so much stuff here. I'm just gonna hide my pretty face here. And by pretty, I mean ugly. So I'm gonna take some examples here with some graphics that I invested in better than these drawings. So you have a Node.js here running on my laptop on port 10003, and then 10002. This is my server, and this guy is the listening socket, right? And what we have is, I wish this thing doesn't show and appear. It's covering my text. But yeah, 10003 wants to connect to 10002 on an open port 8080. So let's go. Let's go through it. What's happening here? So what we do is we listen on the. This is also running Node.js, right? We run a listen command, create a server, and we listen on 10002 on this port. That creates a file descriptor, a unique file descriptor, because in Linux everything is files. Everything is a file. And that, once this is created, we get an on listening event, right? And depending, I talk about this a little bit, right, in the polling phase lecture, where depending what did you do, this could either fire in the initial phase or at the poll phase. If you only bind to 8080 and all ports, then you just you're gonna get it in the initial phase, the listening event, right? You're not gonna wait until the poll phase to actually DNS this and get the actual IP address and create all that stuff, right? So it's going to happen on the initial phase. Sometimes it can happen on the poll phase. But regardless, eventually you're going to be ready to accept connections only when the bind happens, only when the listen system call actually is called. So 10.0.2 is called again. We get a file descriptor and fires on the listening event. And what next? Now this guy 10.0.0.3 knows the IP address. It knows the port, and it says, "Hey, I want to connect." So it says attempt to connect, right? So that it creates a socket. It binds the socket to the destination, right? And while we don't really physically call bind in Node.js, Node does us a favor and simplifies our life by calling a function called connect, which actually creates a socket, and by default it binds it to the destination and also binds it to the source, to a random source and port. Okay, once that happens, we hit the poll phase, and what do? We do a syn, synac, ACK, and this guy is called the three-way handshake. And the reason we do this is to exchange information between the client and the server so we can synchronize sequence numbers. That's the main reason. The other reason is just to exchange metadata about the client and the server, such as the window size, parameters like that, the MTU, interesting things like that, so we can know more about the server. So, but once we synchronize these things, the connection is considered established. Again, check out my TCP course. I don't have a TCP course, I have a network course. And once that connection is successfully, once that ACK is received, then the connection is considered completely created. And what did we get? At the client side, we get a brand new file descriptor because the connection is created, and we fire an event because we're going to talk about Node, how Node does it, guys. When are these events actually firing? Is when that connection is being completely established. So if there was like a problem here, let's say we never received this, that event will never fire. Okay, so we get that, and then we get a brand new file descriptor at the client side. How does it look like? The destination is 8080 10.0.0.2. The source is random port assigned usually by the kernel, and a random, the actual source IP that is applicable to connect to that server. Like in this particular, and this is like a complex process. Not complex, but it needs some work to be done, right? Because here's what the problem is, right, guys? And instead of looking at a static image, I want to tell you something, right? Your laptop, your machine has multiple network interfaces, i.e. you're connected to the Wi-Fi. You're probably connected to an Ethernet. You might have a direct DSL. You might have a fiber optic cable directly from your laptop. It's unlikely, but let's say you have. You might have a Docker installed, and you have a network, a Docker interface, which has also, all of these guys have IP addresses, right? And of course, you have loopback, which is 127.0.0.1. And if your kernel is relatively new, you also have another loopback, which is called the ::1, which is the IPv6 loopback, right? IPv4, IPv6, and in each of these guys, you can have two IP addresses: one IPv6, one IPv4, one IPv6, one IPv4. So, which IP becomes the source IP that this guy, the server, right? That the server picks to connect back? You don't know. You have no idea. So based on where are you going, the Node.js with the collaboration of the kernel, knows that, well, this guy is going to 10.0.0.2. I'm scanning. I see the most applicable IP address is on this network, so I'm going to pick that. Right? If you're going to 127.0.0.1, you're not going to pick the IP address of your Ethernet connection, right? Because that is going to have a different IP address. You're going to pick the loopback one, right? If you're going to an IP address that is in the subnet of your Wi-Fi connection, then we know that, oh, it's the same subnet. Then this is the most applicable one. And there is a cost to that, right? And this is where networking comes into the picture. This is not free. It's not magic. There's work that's going on here. So which IP is being picked is interesting. So sometimes, I believe you can do it. Definitely in UDP. I'm not sure about TCP. You can tell Node, stop guessing. I know where I'm going. Pick this IP and run with it. All right? But this complicates things, and we programmers, unfortunately, like things to be done for us all the time, right? This is also good or bad, because of course I have other story points I have to finish, and features and product owners that yell at me, right? And at the same time, I also need to understand what I'm doing. So it's a trade-off, really. All right. Regardless, so that's what we pick. We pick this guy, and then we get a connection. Now we have a connection at the client side. Guess what? Server is also getting another connection. Not another connection, a new connection. Different file descriptor. This is the listener, remember? This is a connection. This connection matches this one. It has the same 4 ports, 4 pairs, 2 pairs, 4 tuples. Is this a tuple? I can never remember. You see, these are 2 tuples or 4 tuples. Doesn't matter. It's just naming convention. You know what I'm saying. So 1, 2, 3, 4, 1, 2, 3, 4. These are uniquely identify the connection. And that's how you uniquely identify connections, right? All the time. As packets come from the network, if they have the same 4 guys, you know exactly which process and which file descriptor to send the data to, right? The kernel job. The kernel is a complex piece, right? So yeah, we get the connection. Good. And then, of course, we fire the connection command. You can do things here in Node, such as a, hey, a new client just connected, right? To you, a server, someone just connected. To the client, you are connected successfully to the server. But the server can have tons of connections. You can only have one. You can have multiple to the same server. You can do anything you want. But often it's just one or multiple. You can have multiple to different servers, right? Nothing stops you from doing that. Again, guys, ask questions. Many questions. Here's just more diagrams to show you that things can get interesting, right? Another client connects here. This guy is 10.0.0.2.80. This IP address is different, 04. The source IP, the source port happens to be different, but we could pick the same because the IP address is different, right? So don't worry much about it. And we have a new connection on the server, 21, 20, 19, 20 and 21, 2 connections. And this guy has 1 connection, 17 and 18. And by the way, guys, I'm picking unique numbers. They don't have to be, right? I just want to, as much as possible, to show a different example. This could be 18. You understand that, right? Because this is a completely different machine, so they can have the same file descriptor name because it's a completely different machine altogether, right? Right. And for all, even if it's a different node instance, it could share the same file descriptor name because file descriptors are not unique, are unique per process, so they can share numbers, Like you can have file descriptor 18 and file descriptor 18, but they belong to different processes. Okay, so you have 10003 writes hello. So now we want to write, right? Well, there's some, by this time you already know how epoll work. You never call write until you did an epoll before that, right? You do an epoll first and you say, hey, is this connection ready to be written to? And if it is, you call write. You never call write directly because, I don't know, something can be blocked. The connection might not be ready, things like that. Yeah, someone else might be writing to this connection. So you need to make sure both for read and write to call epoll. Epoll before, epoll wait. And of course you set it up before that. Okay, we have 8080. We're writing hello. So what is happening here? I'm writing hello. I sent the hello, but this write is the system call write, right? So there is a Node.js version of the socket dot write. So we send it over. What happens here is at the server side, we're calling epoll wait on all the connections really. And when something happens, we're notified. Node is notified that, hey, something is there. So Node is going to call read on that connection, and that will be translated to something called on data and as an event, which is very, very convenient. If you write your own C application, you will have, there is no nice on data event, unfortunately, right? There's just, hey, read. If there is something happening, you read it, you attempt to read it. And so you have to ask, is there something? And then if the kernel will say, yes, there is, and then you turn around and says, okay, give it to me by calling read, right? So Node doesn't really expose read at all. There is no read on connections because it says like, you don't have to, you don't need to, because hey, I'll take care of it for you in the background, which is very nice of them, right, to do. And of course, when the read happens, we fire the on data event, and then that will copy the data, the hello from the kernel to the Node.js backend application. Okay, so there is a memory copy operation that is happening here. 10002 writes word. So the server writes back something very similar, right? Sending it back here, and then we're firing the on data event on the connection object that I'm listening on, right? So in this particular case, it's 18, right? I'm listening on that connection dot on, and I set up a callback. So what is happening behind the scene is Node is calling read, and whenever there is data, Node calls my callback, which is the on data file event. Let's go through the example. Does that make sense, guys? Let me know. Okay. So this is the network socket library for Node.js net. We've seen it because we used it to demonstrate some stuff in the phase, but it's only high time that we actually explain it in details in this lecture, right? So network, it is built in. You don't need to install it. When you require it, it just lives with the installer. It's in the global node modules location. Did we talk about the global node modules? I don't believe we did, huh? So when you install node modules, there is like a global node modules when you install node. And then there is a local node modules when you install your own packages. So you look first in the local one and then on the global one, right? So that's it basically. So this is installed in the global node modules for you. Always available. We create a socket. We want to connect to a server that exists. Example.com is always the good example here. What I want to do is I want to connect immediately, I'm going to do a timeout here, right? After 0 seconds, immediately connect. After 10 seconds, I want to write something. And after 20 seconds, I want to close. And connect to example.com. And it sets up, I call it client, the object client here, but you can call it connection. And the client.connect does what we talked about, right? It creates a, well, this is a socket already. The socket's already being created for you, right? So you just call .connect to actually bind it. Okay? So this binds port 80 to this IP address. And then when the connection happened, please go and call this callback, right? That's what I did. I don't know why I wrote it this way. It's just weird. I think I was experimenting and I wrote it in this bizarre way using the templates. Anyway, yeah. So we'll be weighted and an IO. Okay, ePOL will be weighted, right? Of course, we're gonna do an ePOL here, and it says, "Hey, right, let's go. Create a connection." Once the connection is created, we're gonna get a brand new connection object, and that connection object, actually, you can get it here. I just didn't show it, but this guy takes a connection object and you can get the information. Actually, we're gonna play with that. We're gonna play so much stuff here. I mean, if we don't do all these things, when are we gonna do it, right? So you might say, what happened if I receive data between here and once I connect and then before I set up the data event? That is fine, because remember, we only call read when we actually wire the data event. If we don't wire the data event, we're not going to call read, right? Unless someone is actually physically reading something, right? So when data is coming to the kernel, it's going to stay in what we call the receive queue for the connection. And unless someone read it, it's not going to be lost, right? So the next data event is immediately going to get read. So we're safe, right? So don't worry, we're not going to lose data or anything like that. So yeah, we call read, and then the data is received, and then they call, i.e. Node.js will call this callback for us, and then we'll pass the data that is received. And this is basically copying it from the kernel after the kernel copies it from the kernel space to the user space, which is Node.js. This is right. We're writing something, just writing something to the client socket, and this is close. Yeah? So this will initiate a write socket. And we're going to see this in live, the data, as we do in strace. Strace is your friend, my friend. Same thing here. The only difference is we're going to do a listen. After 10 seconds, we're going to do a connect. After 20 seconds, we're going to do a write. After 30 seconds, we're going to do a close, right? And listen is going to create a listener event. We'll listen on port 8080. So this is a direct listen. So that is going to happen in the initial phase. Supposed to be, right? We're going to wire the listening event, right? And then we're going to wire the on connection event, which is interesting. On connection event is an event that when we accept a connection, we call this callback. They call this callback to us. And I just printed the remote port here in this particular case. So the remote port, you guys, is the local port of the connection from the client perspective, right? So we know you can use it as, you need really both the connection.ip address and the remote as a unique identifier for the connection. And you can build so much cool applications here. I think I built like a multi-level multi-user chatting application using Node.js, using exactly this approach with a simple client. So we have the client, and the client here in this case, we're gonna connect to myself, right? So it's interesting. So we're gonna connect to itself. We're gonna close, and we're gonna write. Sounds good, you guys? Simple enough. So we talked about that. Node polls for I/O. There is an accept, there is a read, there is a write. There's other approaches too. There is always a socket in the server side, there is a socket in the client side, and there's a connections, right? How about we do a trace and we do node and we play with all this stuff, you guys? Let's go. And for that, we're gonna go to my friend, my Linux machine. Okay, guys, how about we do vim socket 13.0 network read. Let's see what we have here. This is the example that we show on the slides. We're requiring net, we're creating a socket, and I have timers here just so we can see the progression of the events as they're being called. How about we do that? Okay, we're connecting to example.com, and then we're wiring the event, and then we're writing something, right? Of course, when we write something, because this is an HTTP server, it's gonna respond with saying, hey, what are you doing? So watch out. Don't loop and don't do a spam to the server, because they might ban you, or they might rate limit you, because just be I'm sending something weird here, but it's gonna just reject me and send me, but it will send me something, an HTTP response that says, hey, you're sending a bad response. So the real thing, if you really want to send an actual HTTP request, we would send something like that, right? You would send something like get/http11, and then you do n I think new, and then you do the host, and then you say www.example.com, something like that, right? That's what you're supposed to send, but it doesn't matter here. We're just sending something. Oh, and okay, good. So yeah, it's just let's just run, see what happened. Good. So we're gonna do an strace on -f-t, and I'm not gonna write it to a file. I'm gonna actually print it right there and then, so we can watch the process as it goes, right? And we're gonna run node 13.13, and let's go. Look at that. There is an open going on here. There is a delay. Something is happening. Oh, there you go. We sent something. We did a wait, and we wrote, and now we get none implemented. That's what and then we're gonna get a close. Right? You followed that, and there's like a bunch of other system calls that we don't really care about. But what we really care about is these guys. Again, I think this should be fixed. Okay, you could save a system call. I mean, that just saves you like a couple hundred microseconds, not much, but I think this could be fixed. Write initiated. This is where we do the write, but I want to go to the socket itself. Here it is. Created the socket, and we got socket 18. Remember, we are a client, right? So we created a socket, and it's a stream socket. It's I think this is exclusive, non-blocking. And then we're going to connect socket 18, which is the file descriptor for the connection. I want to connect it to this IP address on port 80, and we're doing a wait on the connection. We need to wait to be able to write to this socket, right? To be able to write to the socket connection. We're interested in 18. Remember, our friends is 18. We did an IO. We wrote 19 is basically write to the screen. 19 is the file descriptor for the screen in this particular case, right? To the terminal, standard output. And then we said, hey, I'm ready to read because I just wrote something. We didn't write anything yet. We're about to. I want to do a write, right? But I also want to do a read. So we do a equal n. I want to prepare this for a write because we already prepared it for a read, right? Remember? We prepared it for a write over here, equal out. And we were allowed to write. Then we came here and says, all right, equal let's do the modification and change it to a read. Okay. Also, to allow also reading from this connection. Then we did a wait. It says, hey, just wait. Tell me whenever you're ready. Do you know what this number is, guys? 91919. This is the timer. Because remember, ePoll wait has an option to wait for a specific timeout. And this is an oddly 10 seconds, if you remember. What does this remind you for? This is exactly the timeout that we had, right? Because Node was smart enough to say, wait a minute, there is a timeout that will execute in 10 seconds. So let's block, not forever, but exactly for 10 seconds. Well, 10 seconds minus 80 milliseconds, just to account for the other work that has been done. And then once you hit the 10 seconds, just unblock, and then let's go and execute the timeout. Which is our second call to actually initiate a write. There are two things. We wrote to the screen, and then we wrote to the socket. We wrote something. And then we immediately turn around and do an ePoll wait, which gives us immediately a result. And then we also did a wait, and we did a timeout because there was another timeout for the close. Remember, another 10 seconds. So we did, and then the server immediately responded to us. And when we read, see, I love this stuff, guys. We read. Once we have an event, you now can read it. We go read it, and then we wrote something to the socket. When we read something, that data that we read, 516 bytes worth, we sent it to the onData event that has been wired prior. And then we printed. I just literally printed it to the screen, right? Then we turn around and do another ePoll wait, and that's it. We just did another ePoll wait, and did continue another read, which gets us like another read. And then we go, and the timeout has been done, and we call shutdown, which is closing this file descriptor. That's the 10 seconds has passed. And then we remove it, then we close. Of course, we remove that from the ePoll. Woo, that's a lot of stuff. But it's exciting. I love this stuff. So now, let's check. What else do we have on the 13? On the listening socket, we have something similar here, right? We have very similar things here, but we have a listening socket, a connection, and then we have a little bit extra, right? So how about we do the same thing here? Dun, 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 is trace, and let's do a listening socket. Look at that. We have our socket right here. Bind. We bind to 8080 on what IPs? All IPs? Where's the bind? Yes, all IPs. Right? We listen. A bunch of stuff we don't care about. We write to the screen 19, server created. We do an ePoll control, and then add the connection 18. Our connection file descriptor is 18, the listener. We add our listener so we can start polling in. What are we polling from listener? There is nothing, no data coming to the listener socket, but there are connections coming to the listener socket, you guys. And we waited for exactly 10 seconds, right? Says, hey, just in case, let's go for 10 seconds. Maybe someone will come in after 10 seconds. And guess what? Someone did come in. And it happens to be the same process. So we're creating a socket connection, 21. We're connecting to the same server, 127.0.0.1. And then we're adding 21 to the same ePoll to start listening on the connections. We're doing a wait for the data for out, right? This really should be both out and in at the same time. And I think they did it right this time here. Look at that. It's actually correct. We're listening on both equal in and equal out. Oh, no. Listen, let's explain what happened here. We did an equal wait and we got two events in this time, right? Because we're listening to 21 and 18. We got something on 18 and we got something on 21, which is the socket connection that is going out, the client. This is the server. What did we get from the server? That's a new connection because we're connecting to ourselves, right? It's a little silly, but it is what it is, right? So I'm accepting on the listening socket, and that gives us 22. Guys, are you following what's going on here? Right? I wish I can draw this, but 22 is the server side connection. 21 is the client side connection. Both live in the same process, but you need two connections, right? One client side connection doesn't mean just because they're in the same process doesn't mean like we're going to share a connection. That doesn't make sense. So 21 is the client side connection. 22 is the server side connection, but they are essentially the same thing. Like if you separate the server from the client, that's going to be the same thing, right? They not the same thing. This is the channel to communicate to each other. 22 or 21, and then of course we have to add our friend. New connection arrived. We connected, and then we add these guys 22, 21, 21 as equal. We have to read from these guys 22 and 21, right? The server side connection and the client side connection. Right? And then we're waiting for 10 seconds, equal for 10 seconds. And then what else? We are writing something to 21, which happened. We received it on 22. So it's like a pipe, right? But it's like a little bit more expensive pipe, Unix pipe, which we're going to discuss in this course as well. All right? Are you following so far, guys? This is exciting stuff. And then equal 10 seconds we have and then finally we initiate a close. We close the connection 21, we close 18, we read something from 22 before we close it apparently, which failed. It's interesting. It looks like I have a bug. I maybe read the connection after I closed it, so something I need to rewrite this. That's fine. So and we close 19. That 19 is the screen. Basically, we close the terminal. And that's it. Isn't this exciting? What do we have else? I have a bunch of other stuff. No, it's all text files. These are just the output from existing runs. But yeah, I think that's it. That's it for this lecture, you guys. Experiment with this. Write your own code. Do an trace. Follow that. Ask more questions. And let's just play with this stuff, you guys. There's so much we can do here. You can, like, I'll try to add some quizzes for you guys or assignments to kind of create like a server and for each connection that is received, put it in an array, right? And maybe print it in the screen, something like that, right? And you can identify uniquely these clients using the source IP and the destination. All right, guys, see you in the next lecture.